In this problem, we're looking at an input of x of t equal to the e to the j omega t, an eigenfunction, and how it is affected by this differential equation. So, since x is an eigenfunction, we know right off the bat that y of t will be some constant h times e to the j omega t. Whatever the frequency omega is here, h is some constant, and then y has the same form as the input x. Alright, so to figure this out, we look at each of these terms. Since y is of this, the second derivative of y, I'll abbreviate that as y double prime, is going to equal h times j omega, the quantity squared, e to the j omega t. The first derivative of y, abbreviated y prime, is going to equal h j omega e to the j omega t. The derivative of x, we'll call x prime, is going to equal just j omega e to the j omega t. And then plugging these back into the differential equation gives h times j omega squared e to the j omega t plus 5h j omega, it's multiplying here, e to the j omega t plus 2h e to the j omega t is going to equal 3 j omega e to the j omega t minus 4 e to the j omega t. And so the first thing to notice is every single one of these terms has an e to the j omega t in it, so we can divide that out. Alright, so the second thing is, since I'm trying to find what y is, I know this because that was my input. I want to know what h is. Well, I've got h here, here, and here, so I want to factor h out of this left side. And what I've left with is j omega squared plus 5 j omega plus 2. That's on the left. And on the right hand side we have 3 j omega minus 4. And again, since I'm trying to solve for h, I divide the left side by this expression, and h is going to equal 3 j omega minus 4 in the numerator. In the denominator I'll have j omega squared plus 5 j omega plus 2, and I'm almost done here. What I really want to know is y. So y of t is h, just write it down again, h times e to the j omega t, which in our case h is just 3 times j omega minus 4 over j omega squared plus 5j omega plus 2 times e to the j omega t. So again, omega, this is the form, and once I know what omega is, I plug that number in here, here, and here, and I've got a constant h times that e to the j omega t. And that's it.